All right, to finish out section 2.3, we're going to look at a general strategy for graphing polynomial functions. Now again, when we're graphing by hand, it is not going to be perfect because we are not computers, but we can manage to come up with a decent sketch that has a fair amount of information, and that's what we're going to do here. We're going to use our graphing calculators as an aid to help us refine our picture, and so that will help us with a little bit speedier process here if we use the graphing calculator to help us refine our sketch. So here's the steps that we're going to follow, and I'm going to kind of highlight these as we go, what the main ideas are. So the first thing that we want to determine is the end behavior for our function. Now, this was what we talked about in the beginning of section 2.3, so you can go back to that video first if you need to, because this is how we put all of these pieces of information together. So first we're going to figure out the end behavior. The second step is to figure out the x-intercepts. That is going to take f of x and set it equal to 0. We also want to determine the multiplicity when we do that, and that tells us how the graph behaves. It's either going to bounce, touch and turn around, or it's going to cross through the x-axis. Step 3 is to find the y-intercept. We do that by plugging 0 into the equation, okay? Now, I will say steps 4 and steps 5 are kind of like good bonus information if you can get it, but 1, 2, and 3 are going to be the most important. These are kind of good if you can get them, but if you don't do those steps, it's quite all right. After you do step 3, you're going to pause to sketch. Take stock of what you have so far and sketch that information on the graph. Then your last step is always going to be to use your calculator to determine some additional key points. Just some points that will help us fill in the gaps a little bit so that we can sketch out a really nice clear graph of the function. So I'm going to do just one example here, and then you can look at the other one that is posted online. So let's work through example 6 together, and then I'm going to let you try number 7 on your own. So number 6, in order to graph the polynomial function, we have f of x equals x to the 4th minus 2x squared plus 1. So let's start down our steps. First step is we want to determine the end behavior. Remember, we look at the leading coefficient, that's 1, which makes it positive. And we look at the degree, which is 4, that's an even number. So positive and even tells us that our end behavior should go up, up. So that helps us determine what's happening on the arrows. Great. Next step, x-intercepts. We want to set the function f of x equal to 0. So where does 0 equal x to the 4th minus 2x squared plus 1? Well, I noticed that I only have 3 terms, so I need to check if this is quadratic in form. It is, because half of 4 is 2. That's what we're trying to see. So we can treat this like a quadratic. So we think what multiplies to 1 and adds to -2, well, that's going to be -1 and -1. The fact that I got the same number on both sides tells me that what I'm getting when I factor here is a perfect square. So this is going to be x squared minus 1 squared. That's what we get when we factor that. Now, I also know when I look at x squared minus 1 that that is a difference of squares. And so I can factor that to x plus 1, x minus 1, but since those came from a squared factor, each of those factors needs to also be squared because you're getting 2 out of each one since it was a squared term. So again, we want that equal to 0. So what are our zeros? If x plus 1 equals 0, then we're going to get -1. And if x minus 1 equals 0, we're going to get +1. Now we need to look at the multiplicities that we have here. Okay, so we have an exponent of 2 and an exponent of 2. Both of those are even, so that tells us we have an even multiplicity, which means in both of these cases, it's going to bounce. So I just make a little note to myself, bounce, bounce. Okay. Y-intercept, f of 0. Well, when I plug that in, I'm going to get 0 to the 4th minus 2 times 0 squared plus 1. Well, that's 0, So we just get 1. So that's our y-intercept. Now, you may notice with this function that it has y-axis symmetry. If you don't notice that, that's okay. It's not going to prevent you from getting a good graph. It's helpful for us to notice that it has a degree of 4, so that means we can have at most 3 turning points. That's something good to keep in mind when we're checking our final answer. But we have a good enough list of information here to go ahead and put that information on the graph so we can decide what key points we might need to take. So our x-intercepts are at -1 and +1, and our y-intercept is at +1. Now, what we know, we're not going to graph this just quite yet because we don't know exactly what's happening yet, but what we know is that this graph has to start with arrows up top on both sides. We know that it has to bounce at both of those y-intercepts. So our guess is that the graph is going to do something like this, turn around, something like this, 2 bounces. Now, we don't know exactly what it's going to do, and so that's where we turn to the graphing calculator. So put this in your y equals and look at the graph, and you can see that we can kind of tell what the graph is supposed to look like. Now, what we don't know is how steep or how wide to make the sides of this W. That's what we need to decide by picking some key points. So the key points that I chose were to look at -2 and +2. Because that's going to tell us, that's just to the right of the x-intercept and to the left of the x-intercept. It'll tell us how tall or how steep we need to make our sides. Remember that you can use the table function on your graphing calculator to plug these numbers in. So you already have it graphed, so just go to your table now and put in -2 and 2. You get 9 in both of these cases. So that tells us that we are at -2, +9, and +2, +9. Now again, if you knew this had y-axis symmetry, you would know both of those. And so now we have enough information that we know pretty much what our graph is supposed to look like. Just enough for us to get a picture of what we need. Okay, you can pick as many points as you want. Like maybe you weren't quite sure what was supposed to happen here in the middle. You could plug in, I don't know, 1.5 or 0.5 and see how high it goes up. We can see from the graph that it turns around at the y-intercept. But if you're not sure, plug in more points. You can pick as many as you need to get a good picture. But remember that I'm always looking for an informed sketch, not just a copy of what you see on your calculator screen, but some specific points, some pre-work, those sorts of things when you're looking at your graphs. So that's a general strategy for graphing polynomials. What's kind of weird is they all come out a little bit differently. But what you can go ahead and do is try number 6B, the one on the next page, and go on in and check your work on the PDF that is posted online. And I'll see you guys later.